Hello guys, I welcome you all to Engineers Academy. Do hit the subscribe button if you haven't done it yet. Now we are going to solve this problem from chapter 3, Hibbeler statics, and the problem says that determine the tension developed in the cables AB and AC and the force developed along the strut ED for equilibrium of the 400-pound crate. So this crate has a weight of 400 pound and that must be acting in the downward direction. So now let's say that the tension in this AB cable that will be acting away from that point A, and let's say that the tension in AB cable is, let's say, T1, and similarly the tension from in this cable AC will be acting in this direction, and that will be, let's say, T2. And since the strut is holding this 400-pound crate in the equilibrium position, so it must be applying the force in the upward direction. So the strut force is acting in this direction, and let's say that this force is represented by F. So we want to find this T1, T2 and this force F. So now we need to find the vector representation of T1, T2 and this force F. And as we know that the weight is acting vertically downward, so that will be the vector for the weight. This is the weight. And it is acting in the negative Z direction. This is positive X, Y and Z. So now I will write T1 as a Cartesian vector. So T1 vector will be equal to its magnitude times the unit vector from A to B, since it is acting from A to B. And we can write the unit vector from A to B as the position vector from A to B divided by its magnitude, the magnitude of the position vector from A to B. So this will be equal to T1 and the position vector from A to B. So to find the position vector from A to B, we need to move along the X, Y and Z axes to reach that point B. And we need to find out the distances between the A and B points along the X, Y and Z axes. So now if I move parallel to the Y axis from A, so I will reach, let's say that if I move from A parallel to the Y axis, so we will travel this much distance along the Y axis, and that will be in the negative Y direction. And from here to here, this distance is 6 feet. So we need to move 6 feet in the negative J direction. So I will write minus 6J. And once I reach here, I need to move this much distance in the negative X direction. This is in the negative X. This is positive X, so this is in the negative X. And this distance is 2 feet. So I will write minus 2I. And then I need to move this distance. So this distance will be, since point B is at a height of 4 feet, and point A is at a distance of 2.5 feet from the Y axis, so this much distance will be 4 minus 2.5. So that is 1.5 feet in the positive Z direction. So I will write plus 1.5 K. This much distance is this 4 feet, this whole 4 feet minus this 2.5. So 4 minus 2.5 is 1.5 feet. So this is the position vector from A to B, and then we have to find its magnitude. So its magnitude will be, we can write the magnitude of this position vector as this 2 square, then this 6 square, and that 1.5 square, and under the square root. So this will give us the magnitude. So that is 2 square is 4 plus 6 square is 36 plus 1.5 square. This gives us 6.5, or we can say that this is 13 divided by 2. So this is 13 divided by 2, or we can write it as 2 divided by 13. Let me write it as 2 divided by 13 into that position vector. So now we can further simplify this. I can multiply this 2 divided by 13 T1 into each and every component. So that T1 vector, this is equal to 2 into 2 is minus 4 divided by 13 T1 I, and then 2 into minus 6 is minus 12 divided by 13 J, and then 2 into 1.5 is 3, so that is plus 3 divided by 13 in the K. So this is the Cartesian vector representation of the T1. Now T2, the tension in cable AC. So again this Cartesian vector will be equal to its magnitude multiplied by the unit vector from A to C, and the unit vector from A to C is the position vector from A to C divided by its magnitude. So this will be equal to T2. And now to find the position vector from A to C, we need to move along the x, y and z axis to reach that point C, and we need to find the distances along the x, y and z axis between point A and C. So to reach that point C, again we need to move along the y axis first. So we need to move from here to here, that is parallel to the y axis, and this distance is again 6 feet. So we need to move minus 6 feet in the, or we can say 6 feet in the negative j. So we will write minus 6j, and once we reach here, then we need to move this distance from here to here. This distance is 5.5, since this point C is at a height of 5.5 from the x-axis, and this point A is at a height of 2.5. So that is, this distance is from here to here, this distance is 5.5 minus 2.5. So 5.5 minus 2.5, this will give us 3, and this is in the positive z direction. So I will write plus 3k, and once we reach here, we need to move 2 feet distance in the positive x direction. So I will write 2I, and then we will find its magnitude. Again the magnitude is 2 square plus 6 square plus 3 square. So 2 square is 4, 6 square is 36, and 3 square is 9. This gives us 7. So the magnitude of the position vector from A to C is 7, and we can write this T2 Cartesian vector. So that will be 2 divided by 7 T2I, since this is multiplied, and we can divide this each and every component by 7. So this is 2 divided by 7 T2I minus 6 divided by 7 T2J plus 3 divided by 7 T2K. And now we need to write this force F, that strut force, as a Cartesian vector as well. So that is force Cartesian vector. This will be its magnitude multiplied by again the unit vector from D to A, or we can write that the position vector from D to A and its magnitude. So that F, and now we need to move from D to A. So to reach that point A from D, we need to travel 6 feet in the positive y direction or in the positive j. So I will write plus 6j, and then we need to travel 2.5 in the positive k. So I will write plus 2.5k. And since this D and this point A, they are in the YZ plane, so there is no need to travel along the x direction. So this means that the x component of the position vector from D to A is 0. So we need to write this as 0I. So this will be equal to, we need to find the magnitude, so that will be 0 square plus 6 square plus 2.5 square. So this is 6 square plus 2.5 square, that is 2.5, this is 2.5. So this gives us 13 divided by 2. This is 13 divided by 2. Or we can write it as 2 divided by 13f. Let me write it as 2 divided by 13f. And similarly, we can multiply this 2 divided by 13f into each component. So the f Cartesian vector, that will be 2. This will become 0, so that is 0I. Let me write it as 0I. Then plus is 2 into 6 is 12 divided by 13 j, and then plus into plus, and that is 2.5 into 2 is 5, so that is 5 divided by 13 k. And now the weight of the crate is acting downward, so we need to write that as a Cartesian vector as well, so that W vector will be equal to its magnitude. So let me write that magnitude as W. We want to find the generalized equation, so that is weight times the unit vector, and the unit vector or we can say the weight magnitude multiplied by the unit vector in the direction of the weight, which is acting vertically downward. So that is the unit vector along that direction is minus k. So this is minus wk. So we can write this as, let me write this weight vector. So its zero component, its x component is 0, j component is 0, and it has only one component that is acting along the negative k direction. Now to find T1, T2 and F, we need to apply the summation of forces along x equals to 0, since the system is in equilibrium. So the summation of forces along x, summation of forces along y, and the summation of forces along z must be equal to 0 if the system is in equilibrium. So to find the summation of forces, to apply the summation of forces along x, we have to add up all the x components. So now the x components are this and these two. So these two are 0, so we can write that this is minus 4 divided by 13 T1 plus this 2 divided by 7 T2, and this is equal to 0. And if I bring this term to the other side of the equation, so it will become minus, and minus will cancel out, and we can cross multiply this 13 divided by 14. So we can say that T1 is equal to 2 divided by 7 into 13 divided by 4 T2. So this will cancel out, so that will be 13 divided by 14. If we simplify this, so that is 13 divided by 14 T2. Now this is T1 in terms of T2, that is T1 equals to 13 divided by 14 T2. Let's say this is equation 1. Now if we apply the summation of forces along the y-axis is equals to 0, so now we have to add up all the j components, so that is minus 12 divided by 13, and this is T1, remember this is T1 and this is T1. So minus 12 divided by 13 T1 minus 6 divided by 7 T2. Now since we have replaced this T1 in terms of T2, so we need to write this T1 in terms of T2 as well. So that is, first let me complete this. So this is minus 12 divided by 13 T1, then minus 6 divided by 7 T2, and then plus this is multiplied by f. Remember, this is multiplied by f. If you multiply this 2 divided by 13 f, so we will have f in these components. So this is plus 12 divided by 13 f, and that will be equal to 0 since this component is 0. So now we have to write this T1 in terms of this T2. So that will be, this is minus 12 divided by 13 minus 12 divided by 13 T1, and now T1 is 13 divided by 14 T2. So now this 13 will cancel out, and this will be minus 12 divided by 14 T2. That is minus. Now we can add up both of these, so we can write this as like this. So minus 12 divided by 14 minus 6 divided by 7, and this gives me minus 12 divided by 7. So this is minus 12 divided by 7 T2 minus 12 divided by 7 T2, or we can write, if I bring this term to the other side of equation, so that will be minus 12 divided by 7 T2 equals to minus 12 divided by 13 f. Minus will cancel out, and if we divide both sides of equation by 12, so 12 will cancel out. So this is 1 divided by 7, and that is 1 divided by 13. So we can write that this T2, if we cross multiply both sides by 1 divided by 7, so that will be 7 divided by 13 f. So this is equation 2, let's say. Now if we apply the summation of forces along the z-axis, the summation of forces along the z-axis, that will be equal to 0. So now we have to add up all the k components. So this is 3 divided by 13, that is 3 divided by 13 t1, then 3 divided by 7 t2, and then 5 divided by 13 f, and then minus w, that is minus w, this will be equal to 0. Now since we can write this t1 in terms of t2, and we have written this t2 in terms of f, so if t1, we can write t1 in terms of t2 and t2 is in terms of f, so we can write t1 in terms of f as well. So we can modify this equation. We can write that t1 is 13 divided by 14 t2, and now t2 in terms of f is this is 7 divided by 13 f. So this 13 will cancel out and we will be left with 7 divided by 14 f. So t1 is 7 divided by 14 f. So now this is updated equation 1. Now we can write this t1 in terms of f and t2 in terms of f in this summation of forces along z equation. So this is 3 divided by 13, t1 is 7 divided by 14 f, that we have just determined this, plus 3 divided by 7, t2 is 7 divided by 13 f, and plus 5 divided by 13 f minus w, or we can write this w on the other side, so that will become plus w. So now this is if we multiply this, so this is 21 divided by, or if we multiply this whole equation with 13, so if we multiply this whole equation with 13, so all these 13 will cancel out and we will have 13w here on this side, so that will be 13w, and this will cancel out. So that will become like this, and now this 7 will cancel out. So this will be 21 divided by 14f plus 3f and plus 5f, and that is equal to 13w. Now we can add up all of these. So that is, so this is 21 divided by 14 plus 3 and plus 5. So this is 9.5f, this is 9.5f. So 9.5f equals to 13w, or we can say that f is equal to 13w divided by 9.5. So this is equation 3. So now we have these 3 equations, and t1 is in terms of f, t2 is in terms of f, and f is in terms of w. And since the weight is given that this is 200 pounds, now if we know the weight, we can find t1, t2 and that force f. This is not 200, this is 400. This is given that this is 400. This is 400 pounds. Now if weight is 400 pounds, we can find that force f. So this force f is 13 into 400 divided by 9.5. So that is 13 into 400 divided by 9.5. This gives me 547.37 approximately. We can say that the force the strut is applying is 547.37 pounds. Now this is that force F which was required. Similarly, we can find T2. So T2, this is T2. So T2 is 7 divided by 13F from that equation 2, from this equation. So this is 7 divided by 13 into F, which is 547.37. That is 7 divided by 13 multiplied by 547.37. So this gives us 294.74. So T2 is 294.74 pounds. And similarly T1, from that equation 1, T1 is 7 divided by 14 into F. Again F is 547.37. This is 7 multiplied by 547.37 divided by 14. This gives us 273.69. So T1 is 273.69 pounds. Now this is the solution of this 352 problem, right? So when the weight is 400 pounds, T1 is 273.69, T2 is 294.74 pounds, and that the force in the strut which is developed is 447.37 pounds. Now using this these same equation 1, 2 and 3 and doing all this effort, we can solve the next problem, and that problem is this one, right? So this is 353 problem, and now this problem says that if the tension developed in each cable cannot exceed 300 pounds, determine the largest weight of the crate that can be supported. Also, what is the force developed along the strut AD? So now this is the inverse problem of that 352. In that problem we were given that the weight is 400 pounds. Now it is said that if the tension developed in each cable cannot exceed 300 pounds. So we can use these same three equations. Let me write all those equations. So that T1 is 7 divided by 14F. We have used that equation, that is T1, this is T1 7 divided by 14F. And similarly we can write that T2 is 7 divided by 13F, and the strut force is, we know that the strut force is, we need to write this equation. We can write this equation, but we need to write now the weight in terms of F. So let's say this is F 13 W divided by 9.5. Now if we write this T1 and T2 in terms of W, right? So that will be, since we have to decide that which cable is in maximum tension, right? So that will be T1, that is 7 divided by 14, and now the F is 13W divided by 9.5. So this gives us 7 into 13 divided by 14 into 9.5. So this gives us 13 divided by 19 into W, or we can simplify it. So this is 0.684. We can further write that this T1 is 0.684 W. Similarly, this T2 is 7 divided by 13, and F in terms of W is 13 W divided by 9.5, and if we simplify this, this 13 will cancel out, and that is 7 divided by 9.5 into W, and 7 divided by 9.5 is 0.736. That is T2 is 0.736 W. So now if we say that, let's say that the crate, if we assume that the crate has a weight of 1 pound. So now if I put W equals to 1, so this T2 will be 0.736 pound and this T1 will be 0.684 pounds. So 0.736 is greater than 0.684. So this means that the T2 tension will be greater than T1, and now T2 is the tension in cable AC. So this means that cable AC is carrying the maximum tension. So now if we assume that T2 is under maximum tension, then we can find W using this equation. So from this equation we can write that W is T2 divided by 0.736, and T2 is, if we assume that T2 is 300 pounds, since if it is carrying the maximum tension, so that is 300 pounds. So this is 300 divided by 0.736. So 300 300 divided by 0.736. So the maximum weight that it can support is 407. So the weight is 407.61 pound. So if the tension in each cable, that is cable AB and cable AC, cannot exceed 300 pound, then the weight that can be supported for that condition is 407.61. So this was the required, right? Determine the largest weight. So this is the maximum weight. We can write that this is weight maximum or largest weight that can be supported. Now it is said that what is the force developed along strut AD? So this is the force which is developed along strut AD in terms of W. So we can write that force F is 13 divided by 9.5 into that weight, which is 407.61. So that is 13 multiplied by 407.61 divided by 9.5. So this gives us 557.78, 557.78 pounds. This is that force F which is developed in the strut. Now we want to verify that whether the tension in T1 is greater than 300 pounds or less than 300 pounds. If that condition is valid, if our assumption is valid or not. So that is T1 is 0.684 into W. W is 407.61. So 0.684 multiplied by 407.61. This is 278.81. This is 278.81, which is less than 300 pound, that maximum tension that it can support. So now the maximum weight which can be supported for this particular condition is 407.61, and the force developed in the strut is 557.78 pounds. So this is the solution of these two problems. I hope this will help you in your learning. Do subscribe Engineers Academy for the solution of such more problems from Hibbeler Statics.